My plan here is we're gonna finish 6-4 and then talk a little bit about the rest of this week and next, and that'll be about it. Before we get going though, I made a small mistake here on this spring example. Take a read through and see if you can see what the mistake is. It's subtle. So it's example 3, right? The spring one. Anybody see the mistake? It has to do with the bounds. What's that?
But you have to add words from 10 to 15.
So you're on the right track. The key is that its natural length is 10 centimeters. So stretching from 15 to 18 is really only stretching from 5 centimeters past its natural length to 8 centimeters. Right? The bound should be like the distance stretched past its natural length. Because if we're not stretching past its natural length, no work is being done there. Does that feel okay? I just got rocking and rolling on that one, and by the time you guys were out the door, I realized that oh, dang it, I did that wrong. It was too late to call you back and be like, wait, we'll just do it now. Okay, that was fine. Our last example here is all of your guys' favorite scenario. A tank has the shape of an inverted circular cone with height 10 meters and base radius 4 meters. It is filled with water to a height of 8 meters. Find the work required to empty the tank by pumping all of the water to the top of the tank. The density of water is 100 kilograms per cubic meter. All right, well, let's start by drawing a picture. It's all of our favorite scenario, right? We love these waters filling up cone situations. I know I do. I don't know about you guys. Just going to kind of draw in some marks from the given information. Everybody okay with the picture I've drawn and sketched in here? So let's think about what is physically happening. All right, what is physically happening here on this? We are lifting the water from the cone up some distance, right? Everybody's okay with that? Now, two things are going to be changing as we're doing this. One, the amount of water that we're lifting is going to change based on the diameter of the surface area on the top of the water, right? Everybody agree? And as the cone empties, the distance we have to move that water is also going to be changing. You guys see that? So we're going to have two variables. One representing the amount of water that we're going to be lifting, and then the distance we have to lift. You guys are cool with that plan? Now, what is the force that's acting on the situation that's generating the work? Gravity, right? So what we're doing is we're trying to lift, some arbitrary surface of this water. Try that again. And we're going to take like just a little teeny little slice of it, where it's going to be like delta x tall. And then I'm going to have like x is the distance that we're going to be lifting. Everybody okay with that plan? In terms of imagining what's going on? So I know that our force is just going to be like mass times gravity, right? And what's gravity, physics students? 9.8. Not 10 in this class. You physics, we're not afraid of decimals in this class. Physics, maybe you're afraid of decimals and call that 10. Here it's 9.8. You're lucky I don't go with 0.81. Really like add in some accuracy. So I'm going to need a way to represent the mass of this water. So I have a volume here dimensionally. I'm going to need to convert that volume into a mass. The way I'm going to do that is using density. What's the relationship between density, mass, and volume? Density is mass divided by volume. It's the amount of stuff divided by how much space that stuff takes up. Right, that's density. So we want to get an expression for mass out of this. So density is going to be, or mass is going to be density times volume. We're told the density is 1,000 kilograms per cubic meter. And the volume of this is going to be the area of the base times the height. So my force should be 9.8 times 1,000 times pi RW squared times delta x. Is everybody okay with that? Okay. And then my distance that we're going to be moving is going to be this x. Maybe I should make this capital D for density, and I'll use lowercase d for distance. Everybody okay with that? So we're going to be then doing the integral of let's do where that delta x is going to become my dx. What's wrong with this thing that I've set up to integrate? What's that?
No bounds.
Okay, so I don't have bounds yet, but there's something else that's also problematic here. Yeah, there's two variables, right? I have an RW and an X. And we're integrating with respect to X. So that RW we need to eliminate. Everybody's okay with that plan? Then we'll worry about the bounds, but the bounds still are on our to-do list, absolutely. So if I look carefully at my figure, hopefully not surprisingly, I see similar triangles, right? Just like we have in all these related rates cone problems that we've done. Shouldn't be a surprise to be like, oh, I need to eliminate a variable in a cone situation. Let me bust out that old friend from related rates and use that. So in the green triangle, I can say I have like 4 over 10. And from the orange triangle, I'm going to have RW over, what is this distance going to be?
X, or 10 minus x.
Very good. So that's the same as this distance. If this is x, and the whole thing is 10, that has to be 10 minus x. So if I multiply both sides by 10 minus x and reduce there a little bit, RW is 2/5 times 10 minus x. Everybody happy with where I've gotten to here? We've eliminated the variable that was the problem. Now ready to set some bounds of integration, then it's, simplification time. So remember, this x is representing the distance that we need to pump this water out of this cone, right? What's the shortest distance that we'll have to pump? 2. And then at the very bottom of the cone, the longest distance we'll have to pump is 10. And that ought to do it, as far as the setup goes. Does feel okay? So, the takeaway I want you guys to have from this last lesson is that when we're doing these integration problems, what we're really talking about in all of these situations has been like an accumulation of something, right? We're adding up these little tiny work calculations and like accumulating a bunch of work. Or in the case of a volume problem, we're taking these little tiny volumes and accumulating all the volumes to get like a bunch of these volumes together to get the volume of the whole thing. Or if you know any kind of rate, if you accumulate that rate over time, what it's going to give you is like a quantity, right? If you have a velocity and you accumulate the velocity over time, it's going to give you a distance. Or if you have like some volume of stuff spilling out, and then some volume of stuff being cleaned up, and you want to accumulate how much stuff accumulated over a certain time, you're just going to measure like out or in minus out, and you integrate that, and that'll accumulate how much stuff has been spilled over time, right? And that's the idea that you're going to see in the AP setting. You're not going to see specific physics problems. I do the physics unit because there's probably several people in here that are thinking they're having of an engineering career and like, I'm going to do some calc-based physics, and probably a whole lot of them, and it's nice to have a little bit of introduction and kind of see how we set these things up and how I can use integration as a way to do these normal algebra-based physics problems where a quantity is that we're, part of our formula is not constant. Like in this case, where force isn't constant. Everybody's okay with that? So tomorrow, one of the things that we're going to do in class is I'm going to give you guys some AP style accumulation problems, just practice. Okay? So that'll be tomorrow. Today I'm going to give you guys some take-home problems that'll be like the same kind of thing you'll see on your chapter 6 test. These will be for test points. So I think I have 35 test points worth of take-home chapter 6 problems. That'll be just like the kinds of problems you'll see on your test. We'll give you those to you today, and you'll bring them back next class. Do I feel okay with that? The plan for the for test 6 then will be the Tuesday we get back. Let's try to knock that out before people have to leave for Kairos, because I don't think it did anybody any favors having to wait and take it after they got back from Kairos. Test 6 people or test 5 people, you guys can all attest to that being kind of a mess. I don't think that was particularly helpful for anybody. So next class is going to be the test 6 take-home portion. Sunday's problem set is 6.4 and 6.5. Next class we'll have the take-home test problems due, and we'll do some accumulation practice, AP style accumulation practice. And then on Tuesday next week we'll take the test 6. Does that feel okay? As far as the test 6 format goes, that's your format. So you're going to have 3 of these rational expression integrals, 2 finding the area between the 2 curves. Notice that those are going to be set up only problems. You just have to set up the integral. You don't have to solve. And then you'll have 4 volume problems. Again, set up only. You just set up the integral. You don't need to solve. Notice part 1 is all no calculator. If you take a look at this guy here, this is pretty much part one of the test. It's slightly shorter, there's less volume and area problems, but this is basically part 1 of the test. So it's excellent practice and preparation for that. Part 2 is 6 multiple choice questions. I have multiple choice practice problems that I picked out on the OneNote. And then 1 FRQ style accumulation problem. We'll practice some of those tomorrow in class, and I have a packet of those problems. I'm going to give them to you now just so I don't forget about it. But this is what we'll practice. This is not an assignment. You can do as much or as little of this as you'd like. We're going to work on these guys tomorrow, or not tomorrow, but next time in class. And that's kind of the plan. Does that feel okay? Timeline feel all right? In terms of like what we're doing, pretty clear as to like what's due when, what's still kind of coming. I would point out to you guys that this bonus integration notes or bonus integration techniques notes will be quite helpful to you for the take-home piece and for studying for part 1. Those 3 methods that I outlined here using polynomial division, tan inverse U substitution, and partial fraction decomposition are the same 3 techniques that you'll see on your take-home and the same 3 techniques you'll see on the test in class. I would make sure that I'm pretty familiar with those procedures. The 4 volume problems, we've calculated volume 4 different ways. Disk, washer, shell, and then other cross-sectional area. There are 4 volume problems on the test. What are you going to expect to see? Probably one of each type, right? Where it would be obvious to do it in one of each type. Obviously, like, if you have a disk problem, you could do it as a shell also. Like, is more often the case, you probably wouldn't want to do it that way, but you could. It wouldn't be wrong. A correct answer is a correct answer, whether you do it the hard way or the easy way. Does that feel okay in terms of like what's going to be where, what's the big stuff to review? Notice that we did this average value for a function that was like section 6.5. That doesn't seem like it's listed anywhere in the test format. Mr. Kulik, where would that land? Where could that be if I didn't list it explicitly anywhere? Or in the multiple choice, right? And that average value calculation was pretty easy. There's just like a formula. 1 over b minus a times the integral from a to b of f of x dx. Or again, the mean value theorem for integrals. Like those feel very much like multiple choice style questions to me. Or like a part in an FRQ possibly. So yeah, I mean, that's what I got for you guys. Does that feel okay? You gonna be ready for tests this time? Felt like we weren't that ready last time, or you'll tell me if you're not ready. Are we ready? Ish? Or can be ready, we think? We feel better about like volumes and stuff than we did about before. We've done a lot more practice. I tried to slow down and give you guys, we did a lot more practice than we had before, right? Just no feedback. Okay. Well, take the take home. Let's do that portion. Okay, come back next class. We'll see how the accumulation practice goes. Okay. You're basically looking at 50% or more of the test as a take home. Then you have to do it again without take home-ness, where you can't look at notes anymore. But if you can do it, you know exactly what to prepare for, like the level of detail you're going to hit. Much like the take-home piece for the volume questions on the part 1 of the test, because it's no calculator, I'll give you a picture much like I did here. Right? Like I give you a picture of the functions and how they're intersecting or whatever, so you don't have to try to graph it by hand, because that's just a big time suck. So I'll give you a picture much like I did on this take-home piece. I don't know, how do you guys feel okay? Just kind of worn out. It's a lot of dancing earlier, you know. You guys have questions for me?
So it was like, how many points is the test that we take in class?
Well, the in-class tests are always 100, because they're just percentage out, you know, like it's a percentage out of 100, so they're scaled to 100.
Okay.
So these mini things have been like in that 30-ish points.
Okay.
So other test points we have other than the 100-point test have been the 30-point related rate. I think it was 12-point for the integration formulas, 30 points for the optimization thing, 35 for this. So you have a little bit over another full test grade when you sum those things together. So again, it's not nothing, right? Again, I felt bad about leading everybody on with having a mistake in the grade book. This is me trying to, like, you know, throw you guys a bone. Here's something that should be easier to do well on as you get to like take home and take your time with it and look at notes and kind of work your way through it. All that. If you prefer, you can do your work for these on a separate sheet of paper, just staple it on to the back. Like I didn't leave a ton of room. If you're a big writer, feel free to do your work on a separate sheet, and that's fine. Depending on how much work you feel like you need to show or how tight your algebra is or whatever, like, that's totally fine to do it separately. Is it okay? You guys gonna live? You seem all really unhappy with me. Kind of? No, we're okay? Okay. I tried hard not to have the test this week, right? I'm trying very hard to give you something to like make you get ready for the test in a way that like will be productive also for you, that you're highly, like it's test points to do this practice beforehand that's gonna be just like the test will be, or at least half of the test anyway, right? Like if you feel good about this and you can kind of figure this out and like identify what to do when based on like what the three-dimensional shape's gonna look like in your mind, you should be in good shape. But yeah, I mean, that's the dealio. So after test 6, we're gonna just look at really differential equations. And then after that, it's going to be some leftover like calculus topics that aren't necessarily AB calculus topics, but I think are important. Would be things I would expect you to see in your first 2 years of college calculus, which is kind of, this is, calc AB is like calc 1.5. It's like 1.5, I would call it 1.5 years of college calculus, or the curriculum is about 1.5 years. Typically in a collegiate curriculum, you'll get to like right at like that fundamental theorem of algebra, of calculus will be like the end of calc 1. And the start of calc 2 will be then like all these integration techniques and formulas and application, and then you'll do sequences and series as like the second half. That we don't do any of that in this course, but I'd like to do some more of these integration technique and application things that we expect to see in a Calc 2. Yes?
Do the integration with parts this year?
I'm going to teach it to you. It's not part of the AB exam, although you could use it there and they wouldn't mark it wrong if you did do it. So we're going to do integration by parts. We're going to look at trigonometric substitutions. We'll look at improper integrals. And those are really the 3 big stray topics that would be in your first half of a Calc 2 course that we don't do in aren't required parts of the AB calculus curriculum. The BC kids do those, and then they do sequences and series also. Most schools run that as a separate year course, though, where you've done AB, and then BC is like, we review AB, and then we do these stray, about a semester's worth of topic. You can ask the HL kids about the series stuff, how much fun that is. It's kind of hard. And I think the BC kids do like calculus with parametric and polar equations, which I don't think we do anymore in the pre-calculus, in the AP pre-calculus, which I find really odd that they don't do any parametric or polar stuff. Well, they polar equations. So like you can do calculus on these things also. You can do the polar coordinate system, I think you guys still do. I don't know if you guys really like talk about the different classes of polar functions, like the Limousin curves and the Rose curves and stuff, and like what those things look like, and yeah. So you do that in BC also. I don't remember doing that in my Calc 2 course though.
So we have one more test after this versus our last.
No, you'll have, the idea would be that we do one more test after this, and then we'll do some straight topics and then do some exam review. would be what I would like to do there. Does that feel okay with everybody? I think that should work. We have, like, after this test, we'll have a little over a month worth of class days, I think. So we lose a week or so for spring break. But we'll be starting this stuff a little bit, like the last week in March, so about a month left of class days to do what I think is the thinnest test. And then, do some review stuff and some dangling topics. What do you guys think? Is it nice to have the end in sight? I know it's a lot. Hang in there, guys. We'll get you there. Just keep reminding yourself that, like, it's like a 70% is like a 5 on the AP exam. Like 50 to, somewhere between 50 and 60 is usually a 4. Like, you don't have to note it all perfectly to do, to get an excellent AP score. The two general strategies are slow and perfect and sacrifice not answering everything, or fast and not perfect and hope that you answer almost everything, but maybe make some mistakes along the way and give up some easy points because you're going faster than you. But those are the two strategies. Very few high school students are ready to do fast and perfect, right? But you don't have to. Like 70% is 5. So if you can go fast and pretty good, or slow-ish and really good, you can do really well. If you're slow and bad, that's hard. That's hard there. But if you get one of the two, you should feel all right. Does that make sense? So once it gets a little bit closer, to May, we'll give you guys some practice exams to look at and practice on. Depending on how much time we have left at the end, we may do some of that in class. But that's the gist of it. Is that okay? All right. I don't know. I don't have anything else to say. I've just been kind of chatting with you guys and talking about what to expect here when you're expecting, How's your Irish week going? Today was fun, wasn't it?
Mm-hmm.
I thought this was the choir was like, I think was the best Irish week choir we've had in a while, right? That was fun. Doing like the pop standards that were like grade leveled. It's a nice change. We don't always do that, do we? They usually do like their choir competition stuff, which I think is a little less fun for the occasion. This felt pretty fun. Mr. Davis was digging it.
Yeah, I think they rented a band. Like those people that will play.
Oh, yeah.
Yeah, they should never do that.
I think those are like the same guys that come in and do like Concert on the Hill stuff, right? Caroline probably knows all about that. You're like a singing machine. That was fun. You guys did good at Trivial Pursuit. I can't believe nobody from my calculus class is on the Trivial Pursuit team.
I was.
You were? Oh, I missed you though. I'm sorry. My apologies.
Why didn't you get the percent right?
Yeah.
Which one?
The percent ones.
Julia Pacwa couldn't get that right, and she's in HL, so
I wrote that question, by the way, because it's the question I get the most in all my math classes. If I have this, what do I need to get on the final to still get this?
That's what final grade
There's
calculates.
an app.
Yeah, exactly.
Yeah. Let me just use the website.
Well, I picked easy numbers, like 0.85 times 100 plus 0.15 times x equals 90.
I think we were 5% off.
Yeah.
Oh, no, you didn't use it.
It would have, like, I picked numbers where it's like you should get all integers.
Yeah.
If you set it up the right way, and it would have been nice.
We still won.
You did still win, you won by quite a lot. And then the rectangular prism was my question.
Right,
So
we did get
I
that.
wrote that one. Yeah.
I don't think you fixed.
Anybody can go start my related rates test.
It's fine with me. If Mr. Emmerich happy to have you, you can come and start. Sure.
Thank you.
Yeah, we're done doing stuff in here, we're just kind of chit chat.
Oh, they said.
Sorry, I said related rates.
I know what you're
Are you coming to Frozen?
Thank you.
Am I coming to, I don't think I'm gonna be able to make that.
I think you're
We have
That's okay.
a jammed weekend.
Yeah, that's okay. What's on this weekend? Free kids this weekend. I don't work Friday. Okay, good.
Yeah.
Okay. Yes.
Break a leg though.
Just for you.
Not literally.
Just for you.
You're gonna like it, I promise.
No, I've seen it before.
Yeah, it's
like
freaky.
She can't hear you.
Oh, that's fine. Oh.
You can just, why don't you just take them all and pass them out?
You brought
That's fine.
Okay.
Catherine? Jevin?
Yours isn't. I know, I said it's not. How'd you ask me to grab it? I didn't know. You asked me to grab it.
Maybe it was your invisible friend.
I swear somebody asked me.
Oh, could be.
It wasn't her, because I already said.
So like, press the button.
Like the
The button.
Snapchat, I said. Excited.